Hey everyone, welcome to today's webinar. We're super excited to have you all here. My name is Luke, and before we dive in, I want to start with a question. Do any of these challenges sound familiar? First, you're hearing feedback that your application feels outdated. Users expect a modern, dynamic, and responsive interface that works seamlessly across devices. Second, you're managing separate web front-end and Java back-end teams, and it creates slow organizational complexity. The handoffs between teams lead to friction, slow development cycles, and increased maintenance costs. And third, when it's time to upgrade your application, the process is often slow, risky, or resource intensive. If you've experienced any of these pain points, you're not alone. And in today's session, we're going to address each of these challenges head on. And more importantly, we're going to share the practical approaches that can dramatically reduce your total cost of ownership while accelerating your path to delivering modern web applications. If you have any questions, go ahead and select the grid in the bottom right-hand corner and select Q&A. So without further ado, I'm pleased to introduce Matthew Hawkins, who will guide us through today's session. Matthew, take it away.
All right, everyone, let's go ahead and get started. So hi, hello, welcome. Thanks for joining us today. My name is Matthew Hawkins, and today I'm going to be walking us through how you can quickly and simply, efficiently move your legacy Java applications to the web and even mobile devices using Web4j. So over the next 20 or so minutes, we'll explore how Web4j helps reduce complexity, lower costs, and future-proof your applications, all while staying entirely in Java. All right, so right off the bat, to start off here, before we dive into Web4j itself, I want to talk about the complexity problem and why it's such an issue in today's technical landscape. So just a quick analogous question here. Have you ever tried to watch TV at someone else's house or at an Airbnb? You sit down, you go to grab the remote, and suddenly you realize that there are 3 or 4 remotes, each one controlling something different. One for the TV, one for the speakers, one for the streaming device, etc. It's confusing and it slows you down, and you spend more time trying to figure out the controls than actually watching TV. And that is exactly what has happened in modern software development. This complexity isn't just inconvenient, it makes development slower, more expensive, and it's much harder to maintain over the long term. And that's the challenge that we're here to talk about today. How do we address what used to be straightforward and why it's become a tangle of different technologies and tools and frameworks? Now, it didn't always used to be this way. In the early days, probably even before my time, if you wanted to build a simple little application like the one here on the slide, it only took a few lines of, in this case, swing code in Java, and you were done. Now, one language, one stack, one team could handle everything. It was straightforward and efficient. Now, of course, this example is trivial, but today, even for something this trivial, it wouldn't be unusual to see multiple stacks involved. A Java backend, a JavaScript or TypeScript frontend, CSS layer, maybe even an API in the middle just to pass some data around. What was once a simple exercise has become a multi-technology project with all the extra cost and complexity that that brings. So today, the landscape looks a little more like this. It's a tangle of front-end frameworks, APIs, back-end services, and databases all talking to each other, all often with their own discrete individual technology. This graphic here just shows a wide variety of tools and technologies that can be used for all sorts of things across the application development landscape. Looking at it, you can start to understand why developers have choice fatigue and end up introducing unintended complexity. Every layer that has its own new technology adds more moving parts, more skills that developers need to learn, and more opportunities for things to go wrong. The result is a landscape that feels bloated and slow and fragile compared to where we started. So breaking down even a simple example into its constituent modern-day pieces, if you modernize or if you build an application with today's split stack approach, you often need a JavaScript front end with some sort of API layer in the middle, your existing or some new Spring Boot backend, and then a database. And so already there, at best, you're working with 2 to 3 languages. So and that's 2 to 3 languages to learn and maintain just to get a form on the screen. With a single stack framework like Web4j, that story is different. Your UI is coded in Java. It talks directly with your Java backend, Spring Boot. And then down to your database, all with a consistent language. It's simpler, it's direct, and it's a lot easier to manage. So these days, this split stack approach creates some real problems. Developers need to master Java plus React or Angular or Vue plus APIs, and they need to really have a good handle on JSON and security layers. That increases the learning curve and it slows teams down. And this is assuming that you have one team responsible for the entire app. The other option that we see often is splitting your team into front-end and back-end teams, which can very easily lead to silos, meaning more meetings, more handoffs, more finger pointing, less productivity. It's a dynamic that's harder to manage, and at the end of the day, it's a higher cost for development. Inevitably, you'll get more bugs, API mismatches, data formatting issues, version drift between layers. So when you compare all of that with a single stack Java solution, you look at one language, one team, one code base. Collaboration's faster, maintenance is easier, it's cheaper, and you end up writing a lot less code overall. So to put this into more concrete terms, we took that little temperature conversion app from a few slides ago and actually implemented it as a modern web app. We started by implementing it using a Java backend and a JavaScript frontend with the infrastructure needed for the communication between the two. And then we implemented a Java backend and a Web4j Java front end. The results looked identical, but the effort in the code was not. And so, okay, of course, it goes without saying that this is a simplistic example, but I think that goes to show that if this is an issue at a small scale, it only becomes a larger issue as the application scales up in size. So let's take a look at the effort put into creating this simple little app using a split stack. And so for us, that means a Spring Boot backend paired with an Angular frontend. So here we're looking at 4 different languages: Java, TypeScript, HTML, and CSS. So these are all spread across multiple files. Even for something this trivial, it quickly adds up to about 120 lines of code. And that's not just extra upfront work. It's also 4 different languages, 4 different technologies that developers have to learn, debug, and maintain over the life cycle of the application. So now let's look at that same application built in Web4j. So here, everything is in Java, just under 30 lines of code across a few simple files, and the result is the exact same working application. Now, of course, I should point out that if you brought in an existing Spring backend, you could see an increase in the lines of code in the backend area. We could add another 30 or so lines if we use the same backend from the previous examples implementation. But even still, you're looking at 30 to 60 lines of code. This is the power of the single stack approach. One language, one code base, one team. Less code means fewer bugs, less to maintain, and a faster time to delivery. And while this example is small, the benefits scale dramatically as applications grow in size and complexity. Another very real and arguably more impactful problem isn't just the upfront cost of building an application. It's the cost of maintaining it over time. Every language, every extra layer of complexity adds weight to long-term maintenance, bug fixes, security updates, team training. And these days, with application life cycles lasting longer than ever, this is a massive consideration. And think of it like an iceberg. The tip above the surface is your development cost, what you see right away. But the massive portion below the surface represents maintenance costs, and that's where most of your budget ends up. So with Web4j, you cut the size of that iceberg down dramatically. Fewer technologies, fewer lines of code, and a dramatically lower total cost of ownership. The payoff is faster ROI and more resources free to focus on innovation instead of maintenance. So, all right, great. Web4j sounds great in theory, but what does that actually mean for your business? Well, first and foremost, costs go down and productivity goes up. You no longer need separate front-end and back-end teams or experts in multiple different technologies, which is going to speed up your development and it reduces overhead. And that also means that onboarding is a lot faster. So now instead of struggling to hire across multiple front-end frameworks, you just ramp up your Java developers quickly and productively. And then finally, you reduce risk. With your business logic preserved in Java and only the UI evolving, you avoid costly rewrites and the disruption that comes with that. One of our customers in the Netherlands struggled with this exact issue. And after trying for years to use React to upgrade their front end, they switched to Web4j. And almost immediately, they started to make some real progress. Patrick Aries is the co-owner of Proden Business Solutions, and he just directly quoted this, saying, "We spent months and hard euros trying low-code and JavaScript front ends, but every approach made things more complicated. Once we switched to Web4j's single stack Java approach, everything just clicked. We onboarded 6 developers in a matter of weeks and finally started making real progress." So that's the kind of transformation that we want for every customer. Finally, there's the long-term benefits, future-proofing. Java has been around for decades, and it continues to evolve in a stable, backwards-compatible way. Unlike many different front-end frameworks, which seem to change every few years, Java provides stability and continuity. So that means that your business logic can remain intact for years to come while the UI modernizes as needed. So with Web4j, you get the best of both worlds. Modern web capabilities on top of a rock-solid Java foundation that's built to last. So now that we've discussed one of the most impactful challenges facing developers today, I do want to quickly introduce my company before moving on to our solution. So Basis International has been around for 40 years. It's a privately held business, and about 25 years ago, we adopted Java as the foundation for our developer tools because we believed, and we still believe, that Java provides unmatched future-proofing for business applications. Our latest product is Web4j, which takes Java applications to the web using an all-with-Java approach. We're headquartered in Albuquerque, New Mexico, with a European office in Saarbrücken, Germany. So we bring both a US and a European perspective to our technology and our customers. So in covering how we propose to reduce complexity in your company's app development landscape, we'll start with WebSwing, which is a tool that we use that lets you run your existing Swing applications directly in the browser instantly. Then we'll talk more about Web4j, our Java framework for building modern responsive web apps. And we'll take a look at how these tools fit into a Java application modernization journey. From there, we'll take a deeper dive into some of the tools and features that make Web4j stand out, including our AI capabilities and our integration with Spring, and an overview of our pricing model. And finally, we'll wrap up with some closing thoughts and leave you with a chance to ask questions and find additional resources on the topics that we covered today. So as mentioned, one of the tools that we use in the modernization journey is called WebSwing. WebSwing comes included with our LTS Plus version, which we'll cover later, and it makes it possible to run your existing Swing applications directly in the browser. And so this is valuable because it gives you a very low effort way to bring legacy Swing applications to the web immediately while preserving your existing business logic, backend, etc. The idea is that from there, you can gradually replace your older UI components with modern Web4j elements, evolving the application over time at your own pace. So in just a moment, we'll take a look at an example of what this can look like in practice. Using this tool means the transition path is smooth. Start by getting your application running in the browser, and then modernize piece by piece until you're ready for a fully responsive Web4j application. So I've mentioned Web4j a couple times now, so let's talk about what it is and talk about how it fits into the modernization journey. So Web4j is a modern single stack Java framework that lets you build applications for the web. That means you can build entire enterprise-grade applications entirely in Java. The UI, routing, security, backend integration, all in one consistent stack. So this gives you a clear advantage. With Web4j, you can reduce the unintentional complexity that comes with today's multi-technology web development stacks. Instead of spreading your team across Java, JavaScript, CSS, multiple frameworks, everything can be done in Java. So the result is faster development, fewer silos, and applications that are easier to maintain and evolve over time. So with that high-level overview of Web4j and WebSwing that we've gone through, let's take a look at it in action. So I'm going to start with the WebSwing tool and show an existing Swing application that was brought into the browser with almost no effort. So from there, I'll demonstrate how you can gradually modernize piece by introducing modern Web4j components alongside the legacy UI. And then finally, I'll switch over to a fully modern Web4j application, and that gives you a chance to see what's possible once your app has been fully transitioned to be a responsive enterprise-ready web experience. So let's take a look at what a Java Swing application that is just ported into the browser as is using our Web Swing tool looks like. So you'll see here as the program initializes, what we see is what you would expect to see from any Swing application. A table, an old form, an old little pie chart, and you can interact with it and run it purely in the browser. Now, in our first stage of rebuilding here, what you'll see is now we've added to that application this map. And this map actually interacts, as you can see, with the information that's coming from the old Swing application, which is pretty cool. There's a bridge there, but you'll see that the rest of the application is still Swing. If we move on to the second stage, then what we've done is we've replaced the old Swing form now with a new modern form. So now we've got two different modern pieces, both of which are interacting with our old Swing table, as you can see. In the third stage, all we've done here is we've now used a modern graph here down in the bottom right. And you'll see, again, though, we're still interacting with that old table. And so in our last final stage, we replaced the table with a modern table. And now what you'll see is a fully modern application that was able to be upgraded in a piecewise approach. So to give you an idea of what a fully fledged upgraded application written entirely in Web4j can look like, I'm showing an example dashboard. And it has a lot of modern components and features, including dynamic charts and tables and this collapsible side menu. If I click on one of the items in that side menu, it navigates us to new pages using Web4j's built-in routing. And as you can see, each of these pages that I'm showing in this app looks and feels like what you'd expect from a modern web application built with any current technology stack. It's responsive, it's appealing, and the best part is that you can use your existing Java backend infrastructure to drive what's seen on the modern Web4j UI. So now, having looked at the problem of complexity and having touched on our company's solution, I want to dig into some of the features of Web4j that are responsible for the reduction of that complexity. So from things like our AI-driven productivity tools, to our strong integration with Spring and the ability to tap into other backend tools, to enterprise support models that fit your business's needs, we're going to take a closer look at some of Web4j's powerful features, all of which come on top of creating modern responsive UIs. So without a doubt, one of the most exciting and new areas in tech right now is AI. And we're working hard to utilize this tool in our framework to make development even more efficient and even more simple. So to that end, we've built in support for AI assistance through an MCP server. And we also offer a UI editor with built-in AI integration that can generate layouts from just a simple text description or even a graphic. And I'm going to demonstrate that here in just a moment. The result is that AI can become, or it can continue to be, a natural part of your Java development workflow, should you so choose. And it can help cut boilerplating, and it can speed up delivery. So looking a little deeper at the MCP server, without going too deep into the weeds here, this feature allows for Web4j documentation, source code, best practices, and other pertinent information to plug directly into popular coding assistants like Claude Code or Claude Desktop, GitHub Copilot, ChatGPT, Amazon Q, Cursor, and any others that support MCP server integration. It's completely plug and play. So you can choose the AI tool that fits your team's style or the tool that they're already using. And these tools will have deeper, more nuanced information on the Web4j API and the features available to them. This means less code just to get an app up and running, faster iterations, and more productive development cycles. Now, continuing with Web4j's AI support, we've also built tools that help you design, prototype, and even create fully fleshed out user interfaces faster than ever. So what I'm showing here is our AI-powered UI builder. It can be used without any AI help. But here, what we want to demonstrate is a pretty powerful feature. You can tell the tool what you want to create, and a UI will be built for you without you needing to assemble it by hand. So here, I'm going to demonstrate how to do this in 3 different ways. The first will be a simple text prompt, asking the tool to create a little address form. The next will be uploading a hand-drawn sketch for a contact page. And then finally, I will go ahead and take a screenshot of one of my favorite login pages created with the JavaScript front end. And then I'll ask the tool to recreate this in Web4j using Java. So for example, here we can just type in generate a German address form. And then after a little bit of processing time, the builder generates a complete form automatically assembled with Web4j components. The cool thing is it's not just limited to text prompts. You can also upload a sketch, even something rough like a drawing on the back of a napkin. So to showcase this, I'll draw a quick contact form and upload it so we can see the results. And I'll just have 3 fields. We're going to start with name here and a little field for text entry. We'll do email, same thing, and a field for entry. And then finally, message with a slightly larger field. And then at the bottom, what I'm going to create is a button. And we're just going to put in here, send your message. What I'll go ahead and then do is upload that here onto my screen. And then the result that you'll see is a modernized UI ready to drop right into your application. And then last but not least, as I mentioned earlier, you're not just limited to using text prompts or pictures of sketches. You can also use examples from live applications. So what I'm going to do here is I'm going to navigate to a website that I'm sure you're all relatively familiar with. And I'm going to grab the login dialog as an example to be recreated in Web4j. So I'm just going to come up here and click the sign in. And then I will grab a quick screen cap of the dialog itself. And then with that saved, I'll go ahead and navigate back to the UI builder and I'll upload that screen cap. And then after a little bit of processing time here, the tool will recreate a version of this login dialog that can be used in a Web4j application. And so what's cool is that this demonstrates a component that was written in JavaScript. And here we're letting our tool recreate it using WebForge fully in Java. So changing gears here a bit, you've heard me mention Web4j as a full stack solution a few times now, and I just wanted to briefly touch on what that means. So Web4j is more than just a UI framework. It's backend agnostic, but it gives you the tools to integrate with any new Java backend or one that you're already using, such as Google DI or Spring, which we'll actually talk about here in just a second. It also includes built-in routing, so you can handle all your navigation and requests entirely in Java without needing a separate front-end framework. And for security, Web4j provides APIs to connect with popular enterprise security systems. And the idea is now that together, these features give you the foundation needed to build robust, enterprise-ready applications without adding the extra layers of complexity that we discussed earlier. So, of course, for many organizations, Spring is the cornerstone of their architecture, and it's widely recognized as the gold standard within the Java ecosystem. That's why we've made Spring integration a priority. With Web4j, you can use our provided API to connect and interact directly with Spring, be that a new backend that you're creating for a new app, or an existing backend you already are using. It extends the value of your Spring investments into a modern web application without forcing you to rebuild everything or rework how the Spring backend is consumed. And soon, Spring Security is going to be supported out of the box, making integration even easier. Bottom line here is that you can build true full-stack Java applications with much less friction than many modern tech stack approaches, combining the power of Spring on the back end with the modern UI capabilities of Web4j, all in Java. So we've discussed a few of the exciting new features in Web4j. Let's quickly go over the pricing model for those interested in a more detailed summary. So we offer an LTS Plus version that's designed for businesses who want direct access to long-term support, compatibility with open source JDKs, and advanced capabilities like our AI tools, UI builder, WebSwing integration, etc. This version is ideal for those mission-critical apps where predictability, support, and advanced tools all matter. And importantly, our pricing is competitive with Oracle's, but more affordable since it's based on concurrent users rather than counting every agent or employee. At the same time, we also have a no-fee path. This is modeled after Oracle's NFTC JDK approach and is well suited for evaluation, learning, or for nimble, smaller scale projects that can move rapidly and stay aligned with Oracle's NFTC versions. Together, these two options mean businesses have the flexibility to choose the model that fits their needs, whether that's enterprise-grade features or a no-fee option for lighter use cases. So, Before we wrap up, let's quickly summarize the key takeaways from today. The first is that complexity is the killer of productivity, maintainability, and ultimately profitability. The more technologies that you pile on, the more fragile and costly your applications become over time. Second, there's a better path. So with WebSwing and Web4j, you can A, immediately get your existing Swing applications running in the browser, and then B, modernize those applications step by step, introducing responsive design, theming, and modern web components, all without a total overhaul of your business logic. Third, Web4j brings new capabilities to the table: AI-driven developer productivity, integration with Spring, and a pricing model that fits both enterprise needs and smaller scale projects. At the end of the day, it comes down to one principle: reduce complexity and maintenance, keep it simple, and unlock faster ROI. So as we wrap up, if there is one thing that I hope that you take away, it's that Web4j makes it possible to move your Java applications to the web quickly, simply, and efficiently, without the risks and the costs of multi-stack complexity. I encourage you to visit our website, check out the documentation and tutorials, or reach out to our team for a deeper conversation. Thank you all so much for spending your time with us today. We're looking forward to helping you build the future of your applications with Web4j. So at this point here, we're going to go ahead and switch over to Q&A. We do have some pre-slotted Q&A questions thanks to our registration. So if you have any additional questions that you'd like to ask that you didn't submit at that time, down at the bottom right-hand part of your screen, you'll see a little grid icon. Just go ahead and click on that, and then there's a Q&A section there that you can submit a question in if you'd like to. But to kick us off, I'm just going to share my screen quick with some of the questions that were submitted. So we're going to start with this one. The first question is, how can I start a Spring and WebForge project? Is there a way to do this setup automatically? It's a good question. Yes, there is a way that you can do this setup automatically. We provide a tool that helps scaffold, kind of bootstrap project for you. I'll actually show that to you now. And it's interesting to note that this tool itself was actually built with Web4j. So it's another good showcase of what a UI can look like purely in Java. But this is our tool. It's called Start4j here. We'll make sure to send all of the links that I'm about to show in follow-up correspondence after the session is completed. So this will be included. But what you'll do here is you just go and fill out all of the information that you would typically expect to fill out for a Java project. And then here in this flavor section, you can just select either Web4j only, which is backend agnostic, or you can choose Web4j plus Spring Boot. And if you choose this, it'll scaffold a project with Spring and Spring Boot kind of included in there for you. So excellent question. Our second question here is, where do I see a list of components that are available in Web4j, like the ones that I showed on that dashboard app, and is that app live? Good question here. So let me start with where you can find the list of components. We'll again make sure to include this as well, but here is our documentation site. And then if you just go over here to the sidebar and the components section, this has a list of all of the available components that we've got, and there are constantly more components being added as well. So feel free to take a look through here. You can see examples of all of the different components and kind of get an idea of the different UI elements that you can use in your applications. As for the dashboard app, yes, it is live. We'll send this as well. But again, feel free to go over and check this out. That link will be sent. You can kind of see what it is that we've done here and what's possible to build with our Java framework, our Java UI framework. The third question that we got was, do I have any more info on modernizing old Swing apps? That is another excellent question. Yes, there is some more information. I'm going to open this link. If you go here to our website, and that's just web4j.com, there's a white papers section up here in resources. Just go to white papers. And there's a couple pieces of, white papers here, pieces of information that'll go over that modernization journey and give some more details really on what that looks like in practice. So if you're looking at that as something that you need to do in your company or in your business, both of these papers have some really good information that will undoubtedly be valuable. So I encourage you to download those and give them a read. And then finally, our last question here was, as someone who is interested in Java backend services and is struggling with the front end, how does Web4j help me? Would I need JavaScript anymore? So another good question. Web4j helps because it keeps the front end side of things purely in Java. And so to answer the second part of that question, no, you don't overtly need JavaScript anymore. And that was kind of the reasoning behind creating this product, is we wanted to give the power of the front end back to Java developers. So no, you do not overtly need JavaScript anymore. Yes, you can do it all in Java. If you want to use JavaScript, we don't gate that off for you. You're welcome to, but it's not overtly necessary. So I'm going to go ahead and wait. That's all of the pre-collected questions that we had from registration, but I'm going to go ahead and just wait here for another moment or two in case anyone has any other questions. Again, that's just down, use the little grid icon in the bottom right of the screen, and then you can use the Q&A tab to submit a question. But otherwise, I don't have any more overt information. We'll make sure to send a follow-up email with useful links and resources for all of those who attended today. Thank you all so much for spending your time with us today. I hope everyone has a good rest of their Thursday and Friday and a good weekend. And looking forward to hearing from you. Thanks so much, everybody.